Hi, so today we'll be dealing with equilibrium constant, which is denoted by a capital K. It tells us about the direction of a reaction. It's unitless, and there are two ways to denote it. So it could either be called a Kc or a Kp. If it's a Kc, that means you're dealing with concentration. If it's Kp, you're dealing with pressure. Now let's see how to write a Kc. So Kc is the concentration of your products divided by concentration of your reactants. But a major point over here is that you have to balance out this equation first. Balance the equation. The reason why you do that is because you would need the moles and then plug it in the as powers. And we'll see how to do that. So over here, I balance it out first. This would be like this, I believe. Now I'll write down the reagents. C3H8. Now the reason why I balanced it was because I need to plug it in these powers. And this is how you write a Kc or even a Kp. Just if you have a Kp, that means that they give you pressures. But let's say we had concentrations over here. And also these square brackets that denote concentrations. Now let's say I get an answer for Kc and that is really big. What would that mean if I have a really big Kc? That would mean, well, in order to get a really big Kc, that would mean that I have more of my products. So that means I have more products available. Similarly, if I get a really small Kc, that would mean, well, in order to get a really small Kc, that would mean that my denominator is really big. My denominator has reactants. That means I have more of reactants. Look at another example and see how to write a Kc for that. Now something important over here is that you need to know that the values you put in for Kc or Kp are the ones that are at equilibrium, not the ones that are at the beginning of a reaction or the end of a reaction. The ones you need are the ones that are at the equilibrium. So over here, I don't need to worry about balancing it because it's already balanced. So squared H2 cube and 2. I'll plug in the values. So 3 squared divided by 1 cubed, and this is just 2. This would give me 9 divided by 2, which is 4.5. Now let's say that, well, over here I had assumed that my reaction is moving forward. That's why I knew that my product is NH3 and then my reactants are N2 and H2. But let's say rather than moving forward, my reaction is now going backwards. How would it affect the value of my Kc? So if that is the way it's going now, if it's going backwards, now my products are N2 and H2, and NH3 is my reactant now. So so another Kc for backward reaction would be Kc equals H2 cube N2 and NH3 squared. If you notice, it's literally like a reciprocal, so I don't really need to write this even now. But if I need a Kc value and I have this, all the working added up before this, I can just straight up take a reciprocal. So I could just do it 2 divided by 9, or I could just say 1 divided by 4.5. That's the same thing. I think I get a 0.222. Not sure, but that is it. My reactants become my products become my reactants because I'm moving in a backward reaction.